Twin time. All right, so sorry I'm not fully prepared here. Kind of at the top here, almost cut off here, but you're supposed to find the vertex form of 3x squared minus 12x plus 4. So I know that the x-coordinate of the vertex happens at negative b over 2a. All right, by the way, a is 3, b is negative 12, and c is 4. So I'm just going to plug all that crap into it. Let me maximize this screen. Why am I showing you such a little screen? So looking back at my equation here, or what I wrote up there, opposite of a negative 12 is positive 12. 2 times 3 would be 6, and that should be a 3. 2 times 3 is 6. 12 over 6 is 2. The x-coordinate happens at 2. To find the y-coordinate of the vertex, I take my 2 and I plug it in. That's all I do. 3 times a 2 squared minus 12 times a 2, add a 4. Now, on a test, you're allowed to use a calculator, but whatever. This is 4. 3 times 4 is 12. This is 24. 12 take away 24 is negative 12. Add 4 back, and I should be at negative 8. So I know that my vertex is at 2, negative 8. Now, what else do I know? That's how we do this stuff, because of things we know, tools that we have in our toolbox. I know the form y is a times x minus h squared plus k. That's what I know. I know the a value from here. And x take away h, well, this is h. That's k. So take away 2, all squared, and then plus k, plus a negative 8. Better written as minus 8. So that's 12. 12 is not a hard problem. 13 is find the product of this. And by the way, it is not, and I mean that, it is not 9x squared minus 4. It is not 9x squared plus 4. It is not either one of those things. It's not that easy. What you're supposed to do is write the thing twice and then FOIL. Write it twice and FOIL. Okay? Sorry, I had to check my messenger. Write it twice, FOIL it out. So 3x times 3x is going to be 9x to the second. 3x times a negative 2 minus 6x. Negative 2 times 3x minus 6x again, and negative 2 times negative 2 is plus 4. Combine like terms, 9x squared minus 12x, add 4. That's the result. It's an easy problem. It's supposed to be a freebie. Give me. A third of you will pick something like this or that. 1 in 3 of you will do it. It is so aggravating. 14 is a solve by factoring. It's the easiest factoring you can ever ask a kid to do. You can pull an x from both pieces. If I pull an x from 7x squared, there's a 7x left. If I factor the x out of x, the remaining factor is a 1. That's set equal to 0. So x is 0. That's by covering up that factor right there. Or x plus 1 is 0. If I solve that little one-step equation by subtracting 1, I get that x is negative 1. So there's my two answers. That'll be multiple select probably. It may not be anything. Might be free response. What are the x-intercepts of y equals x squared plus 7x minus 30? An x-intercept happens when y is 0. So 0 equals x squared plus 7x minus 30. In order to use the zero product property, I have to be factored. It takes an x and an x to create x squared. Factors of 30 are probably 10 and 3. The reason I focused on 10 and 3 is because 10 minus 3 is 7. Last I checked. Using the cover-up technique or the zero product property, 0 is x plus 10 or 0 is x minus 3. Those are both one-step equations. Negative 10 is x or 3 is x. So those are my x-intercepts, negative 10 and 3. All right, 16, something that's worded, sounds horrible until you actually read the whole thing. But anyways, a student is going to throw a water balloon off the top of a building. And I give you the setup. Negative 16t squared plus 128t plus 30. If you were analyzing the given equation, what would be the y-intercept? The y-intercept happens when x is 0. In this case, when not x, but time is 0. So height of 0 is negative 16 times a 0 squared plus 128 times a 0 plus 320. And of all the kids in Algebra 2, and there's 90 of you, 20 of you will miss this. I don't know why. It's called apathy. Don't know, don't care. That's all I can come up with. The height at 0 seconds is 320 foot. 320 feet in the air. All right. This needs to be reworded. That would not be an 85-story building. That might be a 32-story building. I actually changed the numbers later on. But anyways, that should be changed to a 32. After how many seconds will the balloon reach its maximum height? That is going to happen at opposite b over 2a. So I'm going to go back and I'm going to look at my equation here. A is negative 16. B is 128. All right. And C, if I need it, it's 320. Probably don't need it. Not yet. So the maximum height is going to happen at negative 128 over twice a negative 16. That's going to be negative 128 over a negative 32, which I feel like is 4. 4 seconds. We're at maximum height. 3 is what is the maximum height. You figure that out by plugging a 4 into this thing. This is going to be negative 256. This is going to be 512, and then 320. So I'm going to have 256 plus 320, which is 576. I'm sure somebody's checking me with a calculator. I don't know. 576 foot. You threw it up quite a bit. The kid threw this thing up in the air 206 feet. That's impossible, but this is a math question, right? You can't throw something 200 feet in the air. But like I said, math question. How many seconds until the water balloon hits the car at the bottom? I probably should have told you how tall the car is, but we're going to assume that the height is 0. It's not. You realize that. It's probably like 3 or 4 feet. But we're going to assume that the height is 0. So we're going to take our little equation and we're going to set it equal to 0. And we're going to hope that Mr. Milbrath created something that factors, because I didn't really think about this thing when I created it. I'm going to pull the negative 16. If I pull a negative 16 from 128, I should get minus 8t. And then if I pull a negative 8 from 320, a negative 16 from 320, I should get a negative 20. So that's the initial factorization. Now I can do guess and check here. I'm just going to guess because I already know I'm right. Factors of 20 are 10 and 2. And if I add 2 to negative 10, bam, I'm at negative 8. So my time is 10 seconds, which is real. That works. That works in the real world. Or my time is negative 2. And that's extraneous because there's no such concept as negative time. A lot of people think there is, but there's not. Small bonus number 2, how fast is the water balloon moving, ignoring air resistance when it hits the parked car in feet per second if the Earth's gravity is forcing it to accelerate at a rate of 32 feet per second? I don't actually know a non-calculus way to do this. In calculus, we take what's called the derivative. So here's an example. The derivative of 5x to the second plus 10x is 10x plus 10. what happened here is I did 2 times 5 and 1 times 10. That's what it was. It was 2 times 5x plus 10. And what you do is you decrease the exponent. It's been a while since I wrote down this rule. The derivative of x to the n is nx to the n minus 1. That's what it is. Anyways, the derivative is also known as instantaneous. That looks horrible. Instantaneous rate of change. That's what it's known as, the instantaneous rate of change. So I'm going to find the derivative of my original function. This was my original function. Height as a function of time is negative 16t squared plus 128t plus 320. Its derivative would be called h prime, and it's going to be negative 32t plus 128. If I want to know the instantaneous rate of change when I hit the ground, I plug that 10 in right there. So h prime of 10 is negative 32 times 10 add 128. That's going to be negative 320 plus 128, which is what? Negative 192. So what does this mean? We're falling 192 feet per second per second. That's pretty impressive. I won't ask for this in miles per hour, but that's still pretty quick. You take 192, that's feet per second, you multiply it by 60, that's feet per minute, you multiply it by 60, that's foot per hour, you divide by 5280, that's miles per hour, 131 miles per hour. That's pretty quick, isn't it? I think it's quick. All right. Stop this one. That way I know it doesn't crash and I lose all my work, and I'll be right back after a break.